What actually happens when you click run? It starts here. Clean, human-readable Java source code. But your CPU cannot read Java. It only understands machine language. So how does this run? Let's follow the journey. Step 1. Compilation. The Java compiler checks your syntax, validates the code, and converts it into bytecode, a .class file. It does this in 4 phases. Phase 1. Lexical analysis. The compiler breaks your code into tokens, the smallest meaningful pieces. So int a equals 10 becomes 5 tokens. Int a equals 10 and a semicolon. Phase 2, syntax analysis. Those tokens are arranged into a parse tree that captures the grammar. Here it's an assignment. The value 10 goes into the variable a. Phase 3, semantic analysis. Now the compiler checks meaning, types, and scopes. If you wrote in T a equals quote, hello, it fails right here because a string cannot fit into an int. That's a compile time error. Phase 4, bytecode generation. Once the code is valid, the compiler produces the hello world.class file. It's not machine code yet, it's bytecode, and any JVM on any platform can run it. Now, most developers think the .class file contains Java code. It doesn't. It contains bytecode. Run java p-c, and your simple addition looks like this. bpush, istore, iload, iadd. This is the language the JVM actually speaks. So what's inside that file? It has a fixed structure. 6 sections the JVM knows exactly how to read: the magic number, the version, the constant pool, fields, methods, and the bytecode itself. The first 4 bytes are always the same. Cafe Babe. Yes, really, Cafe Babe. It's how the JVM instantly knows this is a valid Java class file. Wrong magic number and it's rejected on the spot. The constant pool is the most important section. Think of it as the class's metadata database. It stores every class name, method name, field name, string literal, and reference. So system.out.println of hello is broken down and stored here as its parts. The method section stores each method's signature, its name, return type, parameters, and access modifier, and the bytecode section holds the actual instructions: iload, istore, iadd, invoke virtual. Step 3, you run Java Hello World. The JVM boots up and builds its runtime memory. 5 areas that live for the whole program: the method area, the heap, the Java stack, the PC register, and the native stack. Step 4, class loading. 3 loaders work: parent first, Bootstrap loads the core classes like string and object, Platform loads the JDK libraries, and the application loader loads your code, Hello World. Loading runs in 5 stages. Loading reads the bytecode, verification checks it's safe, preparation allocates static memory, resolution turns symbolic references into real ones, and initialization runs your static blocks. Verification is exactly what stops malformed or malicious bytecode. Step 6, the JVM creates the main thread and pushes a stack frame for your main method. That frame holds 3 things: the local variables, the operand stack, and the return address. The JVM is a stack machine. The first instruction, bpush10, pushes the value 10 onto the operand stack. Then bpush20 pushes 20 on top. Now 2 values are sitting on the stack waiting. Then iadd does the work, and it pops both values, adds them, and pushes the result 30 back onto the stack. That right there is how the JVM computes a plus b. Step 8, the bytecode reaches the execution engine. The interpreter runs it 1 instruction at a time, simple but slow when the same code runs over and over. That's where the JIT compiler comes in. It spots hot code, a loop that runs millions of times, and compiles it into native machine code. And here's a myth busted: Java isn't just interpreted. Modern hotspot tiers it: interpreter, then C1, then C2, profiling and re-optimizing as your program runs. Step 9, the final step. The machine code reaches the CPU, which runs real hardware instructions: move, add, store, and finally prints 30. From Java source all the way down to a CPU instruction. So here's the entire journey on one screen: source code, compiled by Javac into bytecode, loaded and verified by the class loader, placed in memory, run by the main thread on a stack frame, executed by the interpreter in JIT, turned into machine code, and finally run by the CPU. 1 run command, 11 steps. Let's lock it in. 1, your source is compiled by Javac. 2, it becomes platform-independent bytecode, the .class file. 3, that file holds Cafe Babe, the constant pool, the methods, and the bytecode. 4. The class loader loads your classes into JVM memory. 5. The JVM links them through loading, verification, preparation, resolution, and initialization. 6. The main thread and its stack frames are created. 7. Bytecode executes using the operand stack. 8. The execution engine runs it using both the interpreter and the JIT compiler. 9. The JIT converts hot bytecode into native machine code. And 10. The CPU executes those machine instructions and produces your final output. That's the whole journey. From one run, fully understood. Quick interview prep. Question 1. Is Java compiled or interpreted? The answer is both. Java compiles your source to platform-independent bytecode. Then at runtime, the JVM interprets that bytecode, and the JIT compiler turns the hot paths into native machine code. Question 2. What's inside a .class file and how is it loaded? It starts with the magic number cafe babe, then the version, constant pool, fields, methods, and bytecode. It's loaded by the bootstrap, platform, and application loaders through 5 stages: loading, verification, preparation, resolution, and initialization. And question 3, how does the JVM actually compute a plus B and what does the JIT add? It uses the operand stack, push 10, push 20, then I add pops both and pushes 30. The interpreter runs bytecode step by step, while the JIT, through its C1 and C2 compilers, compiles the frequently used code into native machine code for speed. And that is Java program execution end to end. You've followed the whole journey, from source code all the way down to the CPU. Now it's your turn. Take the topic test to lock in your understanding. 5 multiple choice and 5 short answer questions graded by AI. The link is in the description below. Good luck.